Okay, so we did a few experiments in class today with a candle. And what we're trying to talk about is how air is a fluid and it can flow around objects. So the first thing, we talked about just when you blow out a candle, what's happening. Holden came forward with a great explanation, and what he said was that when I'm moving the air, it creates a vacuum around the candle, and a candle needs air to survive. It consumes air. So the vacuum created by the moving air puts it out. Now we're going to try putting some objects in front. So we started with this book holder. And we put it in front of the candle. And I asked students, will I be able to blow it out from here? And there were some really great responses. Some people said, well, by the time the air goes all the way around, it won't be strong enough, there won't be enough pressure, or the air might hit here and just go everywhere. And then I think Holden even said, well, the air can get to it, but by the time it gets there, the pressure is too light, it won't make a vacuum. So let's try. Did it flicker?
No.
Nothing, hey? Look at that. So it looks like the air is spreading out around the flat surface. Then we tried with the coffee cup here. And some people noticed that the coffee cup has an aerodynamic or fusiform shape. Some people predicted that the air might flow right around it and meet up on the other side. And when I did this, right between me and the candle, the air seems to be able to blow it out, although it did take a couple of tries, didn't it? So students said, well, maybe it's because it takes less time to go around. So they were thinking that it was all about the distance. So we tried this. These two objects are about the same shape, or size. So it takes about as much time for the air to go around. So we figured it wouldn't lose as much pressure. But the shape seems to be different. It's not as aerodynamic. The air doesn't seem to go around. It seems the flat surface spreads the air around. So then we tried this experiment, and we took our same coffee cup to the tray here. Can I get your help, please? Now what we're going to do is we're going to tip the tray and pour some water, and what you'll notice is that the water, hold on, will go around, and some of it will meet up on the other side of the coffee cup. Try it now. You'll notice some of the water seems to meet up on the other side of the coffee cup. And so it appears that air wants to flow around and then meet up on the other side. Thank you. Let's try one more time. Now let's try with this somewhat square object. It will still meet up on the other side. Please pour. But it won't meet up quite as well. Do you see the vacuum that seems to happen on the other side? It seems to separate more. Thank you. Let's head to the board. We decided a few key words that might help us in explaining this are impact, flow, around, pressure, water, air, fusiform, fluid, and vacuum. And I might even say aerodynamic might help as well. And here's some diagrams. If this is the top of my head, there's my glasses of course, and I'm blowing air, the air seems to travel around the coffee cup and then meet up on the other side, blowing out the candle. When I did that around the square object, it looks like it seemed to scatter and not meet up on the other side in order to blow out the candle. Here's the cup with the water flowing. It did the same thing. It went around and met up on the other side. Two questions that we have. Number one, why does air go around the bottle easier than the book holder? Number two, why didn't the candle go out when Mr. E tried to blow out the candle behind the book holder? The book holder was the wooden flat object. In answering these questions, you should try to use your keywords. Diagrams always help. Let's see if you understand what happened. Thank you.